All right, so up next we have Patrick Chang, who's a regional senior architect, is that right? Something like that. All right, with F5. He was on the panel earlier, so I'm going to let him come up and go ahead and kick off implementing IPv6 services with reverse proxies.
Hello. I want to start off actually with some questions for you. I'd like a show of hands. How many of you are pretty much networking engineers? Pretty much everybody. Does anybody, work with the application teams at all, or are you application developers? Are any application developers? Okay. So very few. So it's mostly a networking crowd. Let me start off with saying that despite me being what we call a regional architect, this is not really a sales pitch, and I'm keeping it fairly generic. So typically, what we see here in your existing enterprise network is that you have this IPv4 service already, and you typically have a load balancer in there because you need to scale. I mean, that's sort of what marks the difference between an enterprise and a startup. And as a result, you already have a reverse proxy in the path here. So in the data flow, right, your reverse proxy is presenting an IPv4 address, and this defines the service. And on the inside, it's connecting to IPv4 resources. So incoming traffic hits your reverse proxy. The reverse proxy terminates the connection, opens up a new connection to the back-end resources, and return traffic goes from the server to the reverse proxy. The reverse proxy is doing some header manipulation, possibly swapping out IP addresses, port numbers, what have you, and then sends the response back to the IPv4 clients that are out there. And so, as has been mentioned many times before, the easiest way then to have IPv6 services is to essentially put an IPv6 gateway in front of your existing service. And so that pretty much looks like this. You've got that same load balancer that you have before. You still have the IPv4 proxy that's facing the outside, but now on top of that you put in IPv6 facing address and a proxy, and you're connecting to the same back-end resources that you were before. Now, you can also, over time, add IPv6 resources on the back end, and perhaps this gives you a migration path to eventually swap out, and then you're completely IPv6 slowly over time. And then at that point, your inside is all IPv6. Your outside, you have IPv6 and IPv4, and eventually you could possibly turn off the IPv4, and then you're all IPv6. But in this particular case, you could see that you're presenting an IPv6 interface to the outside world. People come in on that reverse proxy. Again, the proxy terminates the connection, and it's opening up a new one to your existing IPv4 resources. But this has some interesting implications as far as the application goes, which I'll go over in a little bit. And then, again, the return traffic comes back from the servers to the reverse proxy. Again, we're manipulating the IP headers and perhaps also the TCP headers as well. And now the reverse proxy sends back the response to your IPv6 clients. Now, at this point, the question comes, how am I going to present these new IPv6 services to users out there in the world or in my local area network? And you have a couple of choices. Like we mentioned before, when Facebook first went IPv6, it was www.v6.facebook.com. And in a case like that, they had a separate FQDN for IPv4 and IPv6. So if you were going to make an A query to www.facebook.com, you would get back an IP address. If you made a quad A, you would get nothing. You would get an NX domain. On the other hand, if you were to send an A query for www.v6.facebook.com, you would get an NX domain. But a quad A request would come back with an IPv6 address. Everything was simple. It worked. It was good for an initial test. But most people would say that you don't want to have too many FQDNs floating out there. I mean, how many names am I going to remember? And so we want typically a dual stack where you have a single name that's presenting both IPv4 and IPv6. In this case, if you send an A query, you'll get an IPv4 address back. Quad A, you'll get a v6 address back. Right? But one of the problems with this is that your operating systems on your new machines are basically going to send a quad A first and then an A. So what happens, right, is that if your client is on an IPv6 network, you're going to send a quad A first, you'll get an IPv6 response, and you'll be connected up, and everything will look like it's good to go. On the other hand, if your client is on IPv4 and IPv6, you make that quad A query, and you'll get back an IPv6 address. You'll connect over IPv6, and everything works fine. Unfortunately, most of your users at home and in many of your corporate networks are on IPv4 only. If they make that quad A query and you give them back an IPv6 address, the app will look like it's not working. Oftentimes, the app will basically just start spinning for a while because it's trying to figure out how to get to an IPv6 address, in which case it'll give up, and the application's not necessarily smart enough to retry the A record, because it said, hey, I sent both and I got back a quad A, so it's good to go. So the question is, what can you do? And we mentioned before that the DNS queries don't come directly from the client. They actually come from an LDNS server. And that LDNS server is based on the infrastructure of either the service provider or your internal corporate network, whatever it's set up to be. So one of the things that you can do is if you can develop a whitelist of LDNS servers, and you say, well, these servers I know are on networks or service providers that provide IPv6 connectivity to all of their clients. So if I'm getting a request for a quad A from one of these good guys, then I know I can accept that and return a quad A record. But for the most part, those LDNS whitelists don't really exist. And in order to generate one yourself, it might take a lot of trial and error. There was a gentleman here earlier from Hurricane Electric, and obviously we could say, well, just give me a list of your LDNS servers and I'm good to go. But obviously they don't represent the majority of the traffic coming out on the internet. So one of the things that you could do as a simple shortcut is to just say, well, if I'm getting a quad A request from an IPv4 address, then I will assume that they are not able to handle it, and I'll return an NX domain and then force them to come back to me with an A record request. Right? This is an indirect approach, again, but it's probably safe, because if the LDNS server is making requests on IPv4, it probably means that that network, that service provider, is set up for IPv6 all the way through. So what does this mean? That you'll end up using IPv6 less than you should? Yes. But on the other hand, the ability to make sure that the application looks right to your end users is probably worth it. The next thing I wanted to go through was the model of the OSI and sort of what this means for us. As you know, we've got the 7 layers starting from the physical wire all the way up to the application. Now, so what does this mean, right? So the IP layer is the network layer, or layer 3. And the TCP UDP transport layer, that's layer 4. And since 4 is greater than 3, it means that pretty much all of that stuff is unaffected by IPv6. It means when you have your services and things, you don't have to worry about port numbers and that sort of stuff. It'll pretty much just work straight through. And a lot of applications now are being protected by SSL. So what does that mean? Well, SSL, again, is at the presentation layer. At 6 is greater than 3. So that too is unaffected by IPv6. You know, your security certs will work the same way. The SSL handshake works the same way. It's independent of the IP layer. And then what about compression? Well, compression is also layer 6. And again, that whole thing about the compression and being able to handle that protocol, that's also unaffected by IP version 6. So at this point, you're probably saying to yourself that, hey, this is pretty easy. Once I set up that reverse proxy IPv6 gateway, I'm pretty much done and ready to go. Unfortunately, that doesn't quite apply at the application layer. So at the application layer, we see that we've got, you know, HTTP, SMTP, client server, custom apps, what have you. And those things are all operating, you know, at layer 7. And you would say, well, layer 7 is greater than layer 3, right? So this too should be unaffected by IPv6. And unfortunately, the answer is no. It really depends on the app. And that's the reason why I asked earlier, you know, how many of you are application developers or working with, you know, your app teams? And the answer is that the networking part of IPv6, for the most part, is straightforward and relatively simple to carry out. There's not a lot of complications there. Unfortunately, at the application layer, it's really app dependent, and you've got to work one-on-one with the application owners, app by app, as you start to migrate these services over. And you know, you would say, well, why is this? And well, the first thing is that, number one, remember I said before that reverse proxy has to open up a connection to your IPv4 resources when you're adding this as a gateway. Well, that connection has to come from an IPv4 address. If the reverse proxy is opening up a connection to your IPv4 servers and it's presenting, you know, a non-IPv4 address, those servers have no way of sending back the data. So what does that mean? It means that your app servers are now seeing the IPv4 address that the reverse proxy created in order to send traffic to it. You don't see the real IP address anymore. Is that okay for your application? Well, sometimes yes, sometimes no, right? And if you think about it, right, you go from 128 bits of information now down to 32 bits. So there's 96 bits of information that's being lost along the way. Is that important? Is there some way to, you know, jam it back in there, right? Well, you think for HTTP, well, hey, that's ought to be pretty simple because I've got this thing called the X-forwarded 4 header, or in fact, any kind of custom header, or even a cookie, right? Which allows you to jam into the header any kind of arbitrary data that you want. So, you know, what does that mean? Well, it means that I can now stick the IPv6 address in to the X-forwarded 4 header, and although I'm opening up a connection to the servers using an IPv4 address, the servers now have access to the IPv6 information. They can go through, and there's a lot of, you know, depends on the web server, but you can configure them to look for the X-forwarded 4 header or some other custom header and record that information instead. And so you would think for web apps, okay, well, I'm good to go, all right? Unfortunately, that's not necessarily the case. You know, the web app servers are recording things, and you're doing some sort of analysis on them for the most part. And the question is, well, can that analysis software parse IPv6 addresses? You know, a lot of them were geared in the old days to basically look at periods as separators, things like colons that they can't handle. You know, the fact that it's not, you know, even a number from, you know, 0 to 9, then they have problems with, right? And another thing that you've got to watch out for is some web apps even actually do some sort of calculations based on the IPv4 addresses that they're seeing. If you pass them IPv6 addresses in there, you will end up with possibly math errors or something else, and now you'll return back some sort of 500 code, which could reveal all sorts of inner workings about the Java structure of your web app server code. So, you know, so basically these are the things you've got to watch out for. And you can't just say, okay, well, I put in the IPv6 address and I'm good to go. So, what are some ways that you can get around this, all right? Well, the first way is, hey, you know what? You can always go back to your app developers and say, I've got to change the application. Let's put in a custom IP stack in the reverse proxy. Maybe I can do some sort of IP and IP encapsulation, right? In order to get 128 bits out of 32, well, you got to do that like 4 times. So that's probably impractical, right? Maybe there's some sort of clever way I can map my source IP address to something that means something to you. Again, it's a lot easier to go from 6 to 4 than it is from 4 to 6, because somehow, like I said, you've got to come up with 96 bits of missing information, right? But, what happens then, if I'm opening up an arbitrary IPv4 address on my reverse proxy and sending that to the real web servers, how do they even know how to handle that? Well, if you had a router in between the reverse proxy and your web servers, you could essentially open up any kind of address that you want. It goes back to the router. The router knows how to send things to the real servers. And on the real servers, if their default gateway is that router, the router can have a static route that says anything that comes back from these servers, I'm going to send to you my reverse proxy. And then essentially in that way, the reverse proxy is able to insert any IPv4 address that you want to the servers, in order to provide some sort of custom mapping. All right, but that gets, like I said, that gets kind of complicated, and again, you lose information that way. Somehow you got to fit 128 bits into 32, but that is one way that you can do that for any kind of application by just playing around with the routers, and that would cause you to flip around the IP addresses in either way, right? And if it were somehow 4 by IP and IP encapsulated by factor 4 times, then the custom stack on the app server might be able to unencapsulate it and basically generate back out the real 128-bit address, right? And if it was encapsulated with zeros or something like that, then it would know, oh, well, this was an IPv4 request, right? Another way possibly is to log things separately, right? Everything has to go in and out of that reverse proxy. There's no reason why the reverse proxy can't sort of create some sort of custom request ID, or if you're on the same NTP server and you trust the timestamps, correlate things via timestamps, right? So the reverse proxy basically can say, hey, I'm sending things to the log server, and I'm going to use the real IPv6 address here in my log message. And when I open up my IPv4 connection to the web server, I'm going to use a magical IP address, some special one that is fake because it belongs to me. And so anytime when you're doing the log analysis, you can look for the magic IP address and say, hey, this one is really an IPv6 request, and I need to go to this other log file and correlate it to figure out who was coming in, right? And so then, therefore, your log analyzer is doing the mapping of the real IP address to the custom request ID or perhaps the timestamp, and then figure that out, right? But then that leads to the other thing, whereas you have to then, most likely you have to update your log analysis system, one way or the other. Either you're going to be able to, either it doesn't know how to parse IPv6 addresses, and you have to go back and figure out how to convert them so that it does, or you got to put in extra logic to figure out how to correlate between 2 log files, who is the real IP address coming in. So, for a lot of web applications that are out there, if there's some sort of accounting going on as to who is using the app and for how long, those are the ones that are your likely candidates for, caring about the IP address of the client. Another type of thing who cares about the IP address of the client or security-related apps. If there's some sort of app where it needs to map the address with the user to verify that, who are they coming from, where are they coming from, that's also probably a candidate that's going to be looking for the real IP address, right? So I just want to, get back to you and say the networking part, for the most part, is straightforward, but the app part is app dependent, and you can't overlook it. And I hope to give you pointers on specific things to look for and possibly what things you can do to work around that. And at this point, I am done and ready for questions. So I just want to remind you that I'm here to answer whatever questions you have, but the fewer questions I get, the sooner you can go out. So anything? Alrighty then. So I hope that I was able to provide you with some specific pointers of things to look out for, and this will help you in your IPv6 migrations. Thank you very much.